Hello, everyone. Thank you again for joining our third AIOps Power Hour of our February series of 2025. So, the way that we want to wrap up our amazing AIOps Power Hour after doing our first session of reducing incidents with event management, followed up by monitoring and Gen AI powered event management. And now we want to wrap it up with health log analytics and how you can reduce outages with this amazing capability that we have as part of ServiceNow's solution for AIOps. So if you didn't know that much about it, be ready to learn a lot, as well as see a fantastic live demo from Will Hallam today, who will be the presenter. And myself, I am Victoria Lowe. I am one of the outbound product managers for ITOM, and I specifically focus on this whole wonderful product of AIOps. And I will be in the background, as well as the rest of the ITOM COE as well, ready to answer any of the questions that you may have today. So I just want to put out a safe harbor notice for any forward-looking statements that we may make in the call, in the chat, in the Q&A. Because all the statements that we're making today are to the best of our current knowledge. However, those are always subject to change. So please keep that in mind. If in any case you're interested in, sorry, I'm looking for my chat tab, attending more ITOM webinars in the future hosted by Live on ServiceNow, please feel free to sign up here in this link that I'm going to be pasting in the chat for all webinars that are for ITOM specifically. So this includes not only AIOps, but as well as visibility and Cloud Accelerate webinars as well. And with that in mind, I want to first ask, our next webinar after this is going to be for, apologies, for what's new in Yokohama. So have you all signed up for that yet? And if you haven't, you could very easily use that link I just posted in the chat. And if you're saying no, you're missing out on a lot of brand new things that I think you should change your answer to signing up now for. But not the biggest deal. I hope you will join me though in a few weeks from now on that webinar. But most importantly, I want to talk about housekeeping next. So today we've saved time at the end for live Q&A, but throughout the session, please use the Q&A module in Zoom to ask questions this way, because it's much easier for us to manage the questions when you put them in the Q&A versus trying to put them in chat. This session will also be recorded and shared on the ServiceNow community page on YouTube. Once Will starts his presentation, I will link the page where the deck and the recording will be posted in about 1 week. And after the event, you will also be prompted to fill out a short survey for your feedback on the session, as well as we will provide you opportunities to give us your information so that we can follow up with you in case you want to learn more about what we're talking about today, or maybe what we talked about in our past sessions as well. And again, the agenda for today is going to be health log analytics, first with an overview, followed up by a demo and a live Q&A. I know this agenda looks short, but trust me, Will has a lot of detailed content to cover, and you're sure to be maybe an expert on HLA by the end of this. But without further ado, let me hand it over to Will.
Thanks, Victoria. Are you able to hear and see me okay?
For sure.
Excellent. All right, let me share out my screen here. I do see a question in the Q&A. What's the difference between APAC and America's EMEA? Is it about the different regions of the world? Yes, it's geographically aligned. That's really, it's the focus is kind of, it's really just from a time zone perspective. Just the content is generally very similar. It's mainly focused on just being centric towards the general time zones of those two kind of geographic super regions. Okay. So welcome everyone. My name is Will Hallam. I'm on a team at ServiceNow called the Americas ITOM COE. We focus on, as our name would indicate, we focus on the suite of ITOM solutions within the platform. And today we're going to be taking a fairly deep dive into health log analytics. Okay, we get my little control panel here. And Victoria, if we could just do a level set with that first poll question, we just want to kind of read the room and see how many folks have seen HLA before. Perhaps they have it and they haven't deployed it yet, or they've actively deployed it. So we just want to kind of get a sense as to who's in the room at the moment. And that's the purpose of this initial poll question. In the meantime, I see a question about what release is my demo system running? It's running Xanadu. I'm sorry, Brandon. I stopped you. I preempted you from answering. Okay, so we've got 9 people who indicate they have HLA in their environment but haven't deployed it yet. One person has it deployed in production, and 24 people out of the 34 respondents don't own it. So this may be a lot of new information for a lot of you. Good to know. So initially, I just want to do a level set on some of the terminology that we're going to be kind of using a lot within our discussion today. The first one is AIOps. So especially with the just kind of skyrocketing of interest in generative AI, sometimes the term AIOps, which has been around a little bit longer than that, um, introduce a little bit of confusion. So I just like to do a level set when we talk about AI ops, that when we talk about AI ops against the backdrop of ServiceNow, we are adhering to kind of the initial definition that Gartner came out with in 2017 or so. And so that has to do with melding together operations, service, and automation with um, value added from components within the ServiceNow platform, namely various machine learning capabilities along with generative AI, all operating with the wealth of knowledge that's stored in your platform, for example, within your CMDB, to provide that business context to what's going on in your environment. And basically having a full feedback loop where you've got operations with features provided by ITOM feeding into service, features provided by ITSM, and turning that, or kind of handing that off into the system of action, which is our automation engine, our ability to create low code and no code flows to ultimately get you to where you can deal with situations in an automated fashion and reduce some of that toil on your service desk, command center, etc. So another piece of terminology, taxonomy, that we refer to a lot has to do with this reactive to self-healing maturity curve. And it's really just a common parlance that we use to characterize where someone is in their journey uh, regarding IT operations management. And so it really just represents a, a 4-stage spectrum, um, where you begin kind of in this reactive mode using legacy tools, a lot of phone calls, emails, and spreadsheets, a lot of disorder. And at most, you've got kind of 20% automation in your environment around managing and maintaining your IT estate. And from there, we progress to level 2, which is a more responsive mode. Up to 40% of what's going on is leveraging automation, but you still got some siloed data. So you can see the impact of changes, but perhaps you're doing some swivel seating to kind of get to that answer. And then level 3 and level 4 are kind of where we generally find health log analytics starts contributing. Level 3 is where you're starting to add intelligence to your IT operations management practices. You're up to 55% automated. And these areas highlighted in green are particular areas where health log analytics has shown to be to start adding value, namely in the creation of proactive alerting, getting to uh, getting into problem solving before it escalates to the point where you need an incident because you're having user or customer impact. Preventing common problems. Essentially, because this is an unsupervised learning system, it can start identifying things that you have never seen before, which is kind of one of the things that differentiates it from more traditional monitoring systems. Because with those traditional monitoring systems, you generally have to experience an issue so that you know that you need to look for it. And then IT operations kind of nirvana is this level 4 where you actually start to introduce self-healing into the equation. So you've got proactive monitoring in place. It has the ability to kind of see the problem before it escalates to the point of causing impact. And then you can feed that into our automation engine as the system of action, which can actually go out and either just notify the needed parties that they need to do something or actually do it on their behalf and completely deflect the creation of an actual IT incident. And so that leads me to this term, concept incident avoidance. And it very simply just describes the situation where you've got something that's starting to go wrong in your IT environment. It hasn't gotten to the point where there's actual impact. And by virtue of seeing that alert ahead of time, before it actually gets to the point of having an incident created, it gives you a window in which you can deflect the actual incident and completely avoid a negative impact on your customers or users. So just to kind of paint where log analytics sits in the overall AIOps world within ServiceNow. This this is a portrayal of kind of all the pieces coming together to create an AIOps experience within the platform. So it starts on the left with business services, which are being provisioned and instrumented and monitored via these various standardized capabilities, all of which can then send data in its various forms into your ServiceNow platform. And so from there, the disparate logs, events, and metrics are correlated via a number of AI and machine learning components, which then kind of pull together uh, virtual alerts, which kind of group those individual notifications into actionable um, pieces of collateral within your ServiceNow platform. So instead of, every time a vCenter goes down, instead of getting an incident for every affected virtual machine, you get a single actionable alert that kind of coalesces all of what's going on into that single actionable record, which is then much more easily triaged by uh, your operational personnel, and then ultimately, remediated by those subject matter experts. So within this larger tableau of predictive AI ops on ServiceNow, the pieces that log analytics contributes to are the AI and machine learning engines, which are doing grouping, correlation, as well as baselining what's considered normal and raising up anomalous behavior. Um, and then the log analytics, which occurs to predict when something is about to go wrong based on that learned baseline of log traffic. And then obviously the source data is all coming in through literally anything that can produce a log that exists within your environment. And so why do we have this capability? What kind of gaps does it fill that are left by a more traditional system of monitoring IT infrastructure? So what we found is that as a result of doing loads and loads of post-mortem meetings after something breaks and there's a 5-hour conference call to fix it, uh, the common thread was that the earliest signs of these problems can be found by looking back, and a lot of times this was done forensically after the fact. The way the root cause would be determined was by going through logs. And there's another picture of logs just in case the first one wasn't uh, on the nose enough. Unfortunately, the challenge therein is that whoops, logs look like this, which even to a subject matter expert are extremely time consuming to correlate and analyze. You can literally run into a needle in the haystack type of situation with a lot of these very chatty application and system level logs. So enter health log analytics. Health log analytics provides proactive log analysis, and it kind of bypasses the need to having subject matter experts pouring through logs after a problem has already occurred so that down the road you know what to look for. And the way it does this is by, in a highly automated fashion, it takes log traffic, such as the little snippet that you see below, feeds it through purpose-built machine learning. It actually breaks down repetitive log patterns and assigns metrics to them. So it tracks a time series of here's how often when things are running normally, we see this type of log pattern in this log stream. And then when something falls out of line is when it just feeds into our standard AIOps event management system to raise those anomalies up as items that need to be looked at. And then in addition, we provide a feedback mechanism that can be used to kind of further tune the machine learning so that it can be taught to eliminate kind of false positives or to flag something as an anomaly, which just happens to be, like a chatty application log. And so the three of the most common anomaly types that we identify in the machine learning is it identifies multiple types of anomalous patterns within log data. These are three of the most common. The first one, deviation, is pretty straightforward. It's after kind of learning what the normal frequency for a given log pattern is. When something steps outside of that normal range, then it will flag that as a deviation. It also has the ability to recognize keywords within a log which have a negative connotation. So generally, if you see log entries with words like error, fatal, um, crash, non-responsive, um, even if it's the first time you've seen that particular message, you generally will it'll generally raise an eyebrow at the very least. And so that's what the new anomaly type is focused on, is those kind of negative sentiment keywords in a log, which even if they're showing up for the first time. And so that's an anomaly that Health Log Analytics will flag as well. And then one of the most interesting ones is this third one on the right side here, the anti-pattern. And so what that is that represents when, like, say you've got a log that every time somebody logs in, it writes an event. And so the system will actually learn what a normal cadence of login activity is uh, for that particular log stream. And if that drops precipitously for some reason, it will also flag that kind of thing as an anti-pattern type anomaly. And so not only, kind of the TLDR is that not only will it find things that it thinks are bad because there's excessive errors or a nasty sounding message that hasn't been seen before, but it will also raise an anomaly if the normal kind of what we would normally consider to be kind of noise in a log, if that noise level drops significantly. Okay, so now just to kind of provide a general flow of how HLA does what it does and how, basically what's involved with, okay, we have HLA, how do we want to turn it on and start getting value from it? So it starts with the data collection and mapping phase. And that consists of configuring one or more what we call data inputs within your platform. Data input is really just a log source. We then provide the ability to do pre-processing on your data. And what that means is if you've got logs, which might contain some type of sensitive data like PII, PHI, and you don't want to send that outside your own, premises, we give you the ability to mask or delete that data before it gets sent into your ServiceNow platform. That's a functionality that resides on a mid server. And so it basically gives you the ability to either drop or just obscure or anonymize pieces of data in a log stream before they actually leave your physical or virtual data center so that you can be assured that you're not sending data that's potentially sensitive out into your ServiceNow instance that doesn't really, that's not material to performing the function that it's being sent out for. And then the kind of the last step in the process of this initial component of HLA is what we call data input mapping. And so that's a semi-automated process. The machine learning within HLA will understand a lot of different log formats on its own without any assistance. The data input mapping provides the ability to tweak that kind of to get it that last yard across the goal line so that it's correctly pulling out key pieces of data such as what application service should this be mapped to? What file format should this be fed into so that it's correctly parsed? Okay, next poll question, just to so given what we've talked about so far, or what you kind of had in your head as far as what you would potentially use HLA for, uh, how do you foresee yourself collecting log data? And so a lot of our kind of the demonstrations and initial proof of concepts that we do leverage our agent, for example, whereas a lot of enterprises have a standard log management solution already in place, in which case best practice is to just kind of fork off a copy of that and send it into ServiceNow. Okay. So a pretty healthy quotient of people interested in leveraging our agent, which is which is one of the it's definitely one of the easiest ways to do it because it just leverages the existing ACC policy construct to automatically start retrieving log data. So it's definitely one of the quickest ways to start gathering logs. Um, but I kind of mentioned early on we can pull in log data from literally any source. It's just a question of um, kind of what's the general t-shirt size of effort required. So what you're looking at here is a new enhancement that was released with our most recent store release of the AIOps experience plugins. And so it consists of integrating health log analytics integrations, which we call data inputs, into the integrations launchpad experience. So previously, setting this piece of HLA up consisted of going to kind of a more legacy list mode, clicking new, and then selecting uh, one of these data input types and then walking through a form. So we've taken our first steps to improving that experience by integrating these selections into the integrations launchpad, which is the same place you go if you're going to add, for example, if you're going to onboard an event source for event management. And so right now there's a subset of the HLA capabilities which are available on that integrations launchpad and launch into a slightly more curated experience. This example here is kind of the more legacy version, which again, it's once you get to this point, it's wizard based. It's got what really has been kind of added in addition to a bit of a fancier UI with the integration into the launch pad is some additional self-testing that's starting to occur on some of the data inputs, which just make the kind of the time to market more speedy because it kind of makes sure it runs some additional integral checks along the way as you're setting up your data input. But even using kind of the older legacy setup, it's fairly self-explanatory for the given. It produces fields specific for the type of log data you're sending in, and then it kind of walks you through each of the steps involved. Once you get to the finish step, it tells you, okay, here's what to do. Like in this case, it's generating some Splunk config files. And then once you reach the finish step, it's going to tell you, okay, here's what you do with these files and how you instantiate the feed from your log data provider. So another capability which we introduced in the latter half of last year, which is um, really helpful for our platform teams is with pretty much 2 clicks, you can point HLA at your ServiceNow platform logs. And this doesn't require a mid server. It's completely handled within kind of internal to the platform. And it has a couple benefits. One is that you can use the log viewer, which comes with Health Log Analytics, to do queries using Elasticsearch query language against your system logs. Um, and for those of you out there who are ServiceNow platform admins, I've certainly felt the pain of trying to look through just a regular, system log listing and try and find a particular pattern or log output from a particular scoped app or what have you. So this capability is really useful for that, as well as the fact that it's also using that machine learning to call out unexpected changes in log patterns that are occurring within your ServiceNow instance itself. Okay, so now we've kind of explored how we start bringing the data in. And now what we'll look at, so we've got our raw log and it's feeding into the next step, which is data parsing and normalization. And so what that means is when we when we bring the log data in, we then kind of split it off into what we call source types. A source type is the HLA term for a file format. So a file format, for example, would be like a standard syslog line, or a standard Nginx or Apache log, or a MySQL log. And so each of those you can have a conglomeration of that kind of log data coming in, and then using the data collection and mapping step, you can fork those off into their appropriate formats. And so once you've got those formats or those source types defined, we do provide the ability where you can actually specify, in addition to kind of the out of the box keywords that I mentioned, those kind of negative connotation terms that are found in logs. You can refine that at that source type level and specify, okay, for this type of log, whenever I see this keyword, I want that to trigger, be triggered as an anomalous occurrence. And then the other piece that this phase lets you do is it lets you assign or reassign or adjust some standard what we call classifications, which is basically it's typing. So in other words, uh, if you've got key pieces of data within the log record that are meant to, for example, if you're storing HTTP return code, you can track that as, a specific, as a meter type of value, so that it kind of clues the system in, hey, I want to keep track of how many 200s versus 500s I'm getting. And then the other thing that this lets you do is it lets you ensure that some key pieces of data are getting pulled out of every log entry. And the three pieces that are the most important and the most kind of just crucial to the rest of the process working correctly are timestamp, severity, and then the actual kind of what we call the inner message, the core of what is this log message actually telling me? And so all of those things are verified and adjusted as needed within the data parsing and normalization step. Okay, next poll question. So we're going to pop up a few kind of common use cases that Health Log Analytics gets deployed for, and see which of those uh, are of interest to our viewers today. Okay, some decent interest in mid-server logs, platform logs. I mean, really, it's kind of distributing across the board, which is great. Um, yeah, of the four, the platform logs, those are pulling platform logs. We kind of refer to internally as the HLA easy button because it's so easy to set up. Um, but really, the tool is built to handle all of that. We do generally, kind of advocate for a phased, a methodical deployment based on some very kind of specific use cases. The general, before platform log capability was available, we would generally lead by saying pick a really critical application and focus on getting in the log data for that first and walk through the process. And then once you kind of get it under your belt, it's kind of just lather, rinse, repeat. But now that we've got platform logs, we basically lead off saying, if you're going to use HLA, turn it on your platform logs. It'll take you about 15 minutes, and it'll let you kind of get familiar with the rest of the tool. An added benefit to that is because of the way HLA is licensed, um, pulling your platform logs is virtually, it doesn't increment your subscription units the way, pulling in server logs would. So it's a very lucrative way to kind of get your feet wet with HLA without, driving, getting a massive immediate spike in your subscription units. So I mentioned that source type is our parlance for file format. And so the source type structure is the record within the instance that tells HLA for a given file format, here's how to pull out those three important bits, the timestamp, the severity, and that inner message. And we'll kind of cover some examples of that when I pivot to the demo. And so then once that source type structure is defined, the machine learning will take this inner message and kind of automatically pull out interesting bits based on its analysis of the data. So the examples here, as you can see, it's going to pull out, okay, what's the client that's being mentioned, pulling that IP address, the server name, the type of request that's coming in. So all of that happens without having to manually write any kind of code. And then it assigns those key value pairs where it kind of characterizes the type of data. And then that feeds into the event management side so ARC only, that stands for automated root cause only. And so that's where essentially the system will automatically correlate any piece of data, any attribute that's tagged as root cause, as a kind of a root cause defining attribute, and it'll kind of correlate multiple alerts that share the same value for that attribute. Invalid, which you'll see kind of throughout the demo when I show you example records. That's really just kind of the catch-all. It's like nothing else applies. It's just kind of a generic attribute to capture concerning that particular log payload. And then gauge is used to measure things like, elapsed time or millisecond response time, that kind of thing, and a meter type of attribute. As I mentioned before, that's a good example of that is your HTTP status code. And this is just a static example of source type structure that I'll show a live one later, but just to kind of highlight the specific kind of important bits, this piece that's circled up here is a raw input sample. So when you start streaming your logs in, the system automatically stores a set of samples, which you can then use to kind of develop and tweak things like your source type structure, where it kind of breaks it down into its component parts. And then down at the bottom, you can see the result of the current configuration. And that's going to be a mix of what the system figures out to do on its own, which you'll see extraction type of automatic extraction. Those are things that the system, just based on its knowledge of that file format, chose to pull out and suggest. And then you've also got script-based extraction type, which are pieces that were specifically coded via this JavaScript entry point that we provide. And this is basically meant to provide, you can put nothing in here, just let the system go with what it is able to automatically derive. But ultimately, you've got complete control over what gets through this stage in the process by virtue of this ability to inject the JavaScript code there. So now that we've parsed and normalized the data, that's where it gets handed off to the machine learning engine for data analysis. And so breaks down the log traffic, creates metrics around common patterns so that it can track how often a given pattern is occurring. So here's an example of a pattern that the system will just kind of pull out automatically. It's, you know, got enough smarts that it it's figuring out which pieces of that log pattern are um, the the static versus the dynamic. So the user, it automatically can detect that this username is a dynamic attribute, and it'll automatically kind of internally wildcard that and file both of those occurrences under the same log pattern. And from there, it generates baselines of what's considered normal levels of each kind of log pattern. And it is constantly comparing the current level with the same hour in the prior day, the same hour in the prior week and month. And if it sees things stepping out of boundaries, then it will create uh, an event management alert or group of alerts. And from there, it just hands off into the standard event management, which is part of our AIOps suite of tools. And so this kind of just shows that entire tapestry of elements. So you've got events, metrics, and logs all feeding into their complementary corresponding ingestion points. And ultimately, it all gets rendered within the service operations workspace, feeding, which is fed both by the ITOM visibility components, such as your CMDB data, as well as the records on the ITSM side, such as change management records, incidents. And then over on the right, we just see the representation of the system of action in the form of integration hub, which is the way that we provide easily accessible mechanisms for reaching out to those external systems, whether it's to reboot a server, restart a service, um, send an external notification, etc. So I've got a couple architecture slides that describe how HLA works kind of under the covers, what the different pieces are. As you'd expect, the Glide platform itself isn't constructed to just send logs into it. So we do have dedicated compute storage resources that are part of your overall ServiceNow platform and communicate with your Glide instance. And so you've got log data coming in from mid servers. Uh, Mid server is required to ingest log data except for that glide syslog type, which communicates, internally within the platform and does not involve anything on the left side. But for everything else, the log data is streaming through one or more mid servers, which are going into the load balancer, which is front ending your ServiceNow platform in whichever data center it's being, whether it's our data center, whether you're running in, if you're running in Azure or AWS. On-prem is in the works. It's coming. Safe harbor applies. But today, on-prem is not available. And so from the load balancer, it splits the traffic off. The raw log data itself goes into our AI engine for HLA, which is referred to as Occultus. And then it breaks that log data down. It stores the raw logs and indexes in a instance of Elasticsearch, and then it breaks down time series data, stores it in a metric base. And HLA has its own metric base. It's not currently sharing the metric base that Metric Intelligence uses. So the next generation, which is coming down the road, I don't think we've got, to my knowledge, we don't have kind of a target delivery for it just yet, but this is kind of the vision. And it basically has to do with improving the parallelism and the throughput. and providing the ability to leverage the ITOM gateway, which is a capability that's already out there for things like Dex. So basically piggybacking on that shared capability and then feeding the log data instead of trying to feed it directly into the AI engine, use our Kafka implementation, which we call Hermes, as kind of the initial landing spot. And then you could have multiple AI engines subscribing to indexes and channels within Kafka to pull the data in. So the whole focus there is to just increase the our ability to drink from the proverbial fire hose.
I will. I will say for HLA 2.0, it is actually already out, but
Oh, awesome.
it's been out. But the thing is that if you have HLA already and you want to use this new architecture because maybe you're having some throughput issues, like you have a lot of logs and you need this new ITOM gateway to be the funnel for all your logs, you just have to work with your account team so that they can work with the product team to enable it. But it's you have to work with us. You can't just request it through the store at this time or through support.
Okay.
That's
That's awesome. So yeah, so um, the the new architecture is really focused on super high throughput. HLA has um, call it HLA Classic, can ingest a lot of logs. It's not, there's traditionally there's kind of limitations on event management, no more than X, events per second. Um, but that's because they're kind of getting ingested directly into the platform itself because HLA has these purpose built and provisioned resources that it is using. We have the ability to pull in, thousands of logs per second, of tens, if not hundreds of thousands of log entries per second. And then we can go even farther with the new architecture, which can be made available by working with your account team. So just a couple of the components that I talked about that I hadn't really explicitly shown so far. This is just a view of log viewer, which is our just native capability to browse the logs that are kept within the system. Um, it is worth mentioning that HLA is not intended for long-term log storage. By default, the raw log data is retained for 3 days. And there are some controls to expand that, but not to 12 months. And the limitation there is just, it's just a very straightforward kind of storage driven limitation within the various data centers that host HLA. So kind of, um, best practice is to just send a copy of logs from your enterprise log management system as opposed to try and replace enterprise log management with HLA. But for the log data that is stored within HLA, you've got the ability to query and view that using Log Viewer. Again, it's really great for looking through your ServiceNow platform logs because it's way better than list view and you can actually write some decent queries. And then another capability, which is just kind of really table stakes when comparing us with other more traditional kind of, filter or regex driven log scraping approaches. We have the ability to statically create an alert. And what that means is you can craft an Elasticsearch query and say for if I see lines in the logs that match this, then when they surpass a certain threshold, then I want to generate an alert. And this is just kind of table stakes for anything that's going to be scraping through logs. Uh, as I've kind of been alluding to, our differentiator is the fact you don't have to do this to start finding things. But if you do have known situations that you just always want to alert on, we've got that capability. And so the idea is to just accelerate operator productivity by capturing these anomalies and then showing them to whoever's consuming the alert. And so this is an example where there's a log spike on an Oracle box, and this is what it looks like. It says, hey, this traffic is anomalous, and it shows you the graph. And then when you look at one of these live and you hover over a data point, it'll say, here's what it was, last week for comparison. And so where this section down here is where that the concept of tagging different attributes in the log payload comes into play, where it says, okay, here's the department data that I pulled out of the different log lines. And it kind of gives further enrichment and decoration around the alert, which further, enables the service desk to more accurately route the problem, as well as um, kind of summarize what's currently going on for those subject matter experts who are ultimately oftentimes needed to resolve the underlying issue. So it wouldn't be a ServiceNow presentation if we didn't mention AI at least once. So all of these capabilities, because they sit on top of our existing AIOps suite of tools, can take advantage of Now Assist for ITOM, which will perform a summarization and an analysis of a given alert or group of alerts. And just, we've implemented this internally and seen just drastic improvements in efficiency as far as not having to, impose on service desk personnel to look at a group of alerts and try and capture a summary themselves. They can click a button and they'll get a summary as well as an analysis, which oftentimes provides some critical breadcrumbs as far as where to look next. And so here's an example where we've got a log entry from the glide syslog. And then when we perform the analysis, it actually directly pulls out the fact that our machine learning trainer data table doesn't have the required 10,000 records yet. So you've just kind of instantly diagnosed an issue, which otherwise would involve, searching on support or relying on an SME who had some arcane knowledge that wasn't commonly within the enterprise. And so just to rehash kind of the use cases that we've talked about so far, the AI-driven anomaly detection, the fact it can pull that needle out of the haystack, which traditionally would be kind of very challenging unless you already know what you're looking for. The ability to detect things earlier, because the logs kind of tell you when somebody lit the match, as opposed to not traditional alerting tools, which generally are only going to go off when things are at least smoldering, if not already on fire. And then the ability to pull in a root cause analysis based on those tagged bits of data in the log payload. And then in addition, just the recently added capability to send platform logs into that. Not only does it help in identifying issues, because the logs can be very chatty, but it provides an improved user interface for searching the logs. Some notable enhancements coming, that are available with Yokohama. We're making HL8 simpler to configure by virtue of adding some additional automatic extraction and classifying of log properties. So we're constantly investing in making that more more automated and taking more of that setup toil away from the customer. And we're also making things more harmonious by virtue of pulling those setups into the existing integrations launchpad. So the integration launchpad piece itself, that's available in the latest AIOps Experience store app. The new data inputs that have been added, those are specific to Yokohama. So in order to get things like what was one of the ones that was only available in Yokohama, Victoria, something like Delta,
Oh yeah, Edge.
Delta vectors.
Yeah, but sorry, I'm just pulling up a slide so I can read it out right now. Give me 1 second. Yeah, so the new data inputs are, yeah, vector agents, Cribble, Edge Delta. And then with the Yokohama, once you upgrade, you'll have Splunk cooked data and Splunk polling, not Splunked. Yeah, those are the few ones that we have for this release.
Awesome. Thank you. Um, so, but wait, there's more. There's actually a resource within ServiceNow that can help customers with implementing a use case in HLA in production for free. So there's a team called the ITOM Innovation Architect Team. And what they do is they implement various ITOM capabilities, among them are HLA. In return, they ask for a clear path to production. One of their metrics is how many production implementations they facilitated. So it does need to be something that ends up in production. And beyond that, they they ask for another metric is their ability to socialize success stories, customers that they've helped to get value from these various ITOM capabilities. So minimally, that consists of a success story slide that can be shared, at Knowledge or with other, like-minded customers to just say, yes, a customer in your industry, for example, is running this in production and getting value from it. They do always enjoy getting kind of a full reference customer out of it, but that's not a hard and fast requirement as long as we can capture a success story of some kind and deploy to production. So if the idea of having free expert resources helping you implement a use case for one of these ITOM capabilities, especially HLA, just inquire with your account team about the ITOM Innovation Architect team and their availability. Okay. So now I'm going to stop the slideshow portion of the program and we'll take a walk through some live examples of the different capabilities, the different kind of components with HLA. Oh, where did my browser window go? There it is. So this is Integrations Launchpad, and I've already kind of filtered out that I want to see the log integrations. I can add the agent client collector options in there too, just to give you the flavor. And so now instead of having to go to an old-fashioned list view, you can pick out the log integrations that you're interested in turning on. And then if I pick, so we've onboarded kind of all of them into that tile kind of layout. There's a selected set that have then got soup to nuts set up in this kind of a workspace experience. And then any that don't will just launch you into a more kind of venerable experience where it launches a separate tab and we'll just kind of walk you through which pieces of information are required to instantiate that particular log input. And we support both push and pull methodologies in addition to using our agent client collector. So the other thing that Integrations Launchpad gives you, and this applies really for any of the data input types, is it gives you these health tiles that will kind of quickly show you the current state of your log ingestion. And so, for example, I've got some agent client collector log analytics taking place, and I can see that I'm pulling in about 4,000 logs per minute on average in the last 12 hours. With the last piece of log data coming in 4 hours ago. I've also got this our syslog based data input, pulling in almost 6,000 logs per minute over the past 12 hours. So it just gives you kind of a finger on the pulse, whereas previous to this, you'd have to kind of drill down into the individual records to see what was going on. Here's an example of the platform logs. Again, it's literally 2 clicks to turn this on, and then I'm gathering all of my Glide log data into health log analytics. Let's see. Here's my agent client collector example. So the agent client collector driven log collection uses the kind of overarching agent policy mechanism that the different functions that work within the agent client collector framework consume. And so in this case, it just very quickly lets me select, okay, for any CI that's of type Linux server, if it's got an agent running on it, then I'm going to collect standard Linux OS logs. And this particular one is out of the box, so it's just basically prepackaged where it'll automatically go to the log files that are generated by standard Linux distributions and start sending them into my mid server. So it's very attractive as far as kind of a rapid startup type thing. It's been especially useful for kind of targeted deployments or for kind of internal pilots, that kind of thing, because you don't have to tie into the big enterprise log management system just to start getting value out of your health log analytics investment. Okay, so now before I get into kind of the second stage, the parsing activity, I'm going to inject a little chaos into my test apps that are running within this system to see if I can generate some log-based alerts in real time. And so this is one of the test applications that I've got running into this demo instance. It's an implementation of a very simple veterinary clinic website, and it's got a handy error simulator that I'll click on a few times here. Just to let that cook while so we're not staring at an alert list waiting for something to pop up. And then I've also, in this environment, it's got some kind of built-in chaos generation capabilities that will trigger some anomalies within the application. So I'll just request one of those. Kick that off. And then I've got an ability to inject some error messages into the system logs. Okay. And so now we'll kind of return to our regularly scheduled programs and look at what we call that file format um, specification. Okay. So when I look at when I create a data input, which is kind of that initial log ingestion point, um, what we what we do from there is what's called data input mapping. And data input mapping is where you can take a stream of log data that's different formats and break it down into the individual formats that need to have their own unique parsing. And so I've done that here by creating some creating some if then logic where it just looks at different parts of a sample log entry and splits it out into the different formats that are coming in through this conglomerated. So this is kind of an example of if you've got enterprise logging and it's pulling log data from multiple sources. We don't require that you split those up and send each different type of log to a different data input if you don't want to. There's flexibility. You can choose to do that, or you can just send them all to us, and then it will split them out into different, the different file formats that it needs to understand. And it's if you need to iterate on that and apply tweaks, you've got the ability to refresh the samples of data that are coming in, where it'll take that log feed, and it'll just take a fresh set of data. So you can see right here the timestamp on my sample that's being displayed has updated. And then it kind of summarizes here if your current set of current logic that you're applying to this type of data is experiencing any errors. And then if there are errors, you can go to this tab here and it will kind of enumerate those. And so this is kind of the ability that you have to kind of validate that the data is getting sliced and diced the way you expect it to. And then the other piece that that I had mentioned in the slide deck is the preprocessor, which is a piece of the process that runs within your data center on your mid servers. And so this is where if you wanted to pull out certain records or just obscure anonymized pieces of data, this is the entry point in which you're able to do that. And again, it's got a test functionality so that you can kind of write some, you can write JavaScript here to correctly call this drop call if you want to drop the entire log entry, or you can manipulate this sample parameter to obscure data that you don't want getting sent to your ServiceNow instance. And as with the source type structure, you can refresh the samples at any time. So if you're modifying kind of the format on the log source end, you can bring in a fresh set of samples and validate it against whatever pre-processing you want it to perform. And we do provide some snippets where you can pull in some template code based on popular log sources. You can also define your own templates to kind of propagate across multiple data inputs. So once you've specified how to slice and dice your stream of log data into the corresponding file formats, then you can look at those file formats and verify that they're being kind of broken down, chunked up into their appropriate chunks as expected. And so an example of that can be found right here. So this is the source type structure that was created for my my Spring based application. And so this is just what the system does without any additional prompting. Now notice it is, if I hit test here to have it kind of run through and parse the samples that it has, it is telling me, hey, you don't have a message or a severity label assigned yet. So it kind of is telling me you're not going to get the most value out of this because it's not capturing severity or message. I can see down here that it's automatically pulling out these pieces. So I can see it's got a timestamp key value pair that it's already labeled as, hey, this is the timestamp. But the other two kind of key pieces aren't getting pulled out. And so I can address that by adding a little bit of JavaScript code. So I've saved off to the side this snippet, and I'll put that in here. And now if I redo my tests, what I can see down here is now I've got a new key value pair called new message, which contains kind of the human readable message that I've pulled out using my little snippet of JavaScript code. And then it's got a key value pair called new sev, which is pulling out the severity. And so I can basically enhance this source type structure by saying, okay, take this key value pair and tag that as the severity, and then take this one and tag it as the message. And what that does is it kind of enhances the machine learning's capability to kind of correlate severity and message content without having to just try and look at the entire payload. It just gives it more focus, which tends to enhance its abilities to identify, avoid false positives and identify the truly, meaningful anomalous data. Okay. And so that's kind of that's the basic process, and it's certainly iterative. So you do this and then you let it percolate and you see what alerts are getting called out. And the way you do that is via back in the service operations workspace, express list, which is kind of our standard alert viewing medium within the AIOps experience. And so you just kind of look at what alerts are getting generated. So for example, here's a group of alerts that were generated as a result of my kind of simulated issues that I started kind of earlier in the process so that thankfully they would be here by the time we got to this part of the program. And so now if I drill into one of those, I can see the subject alerts that have been grouped together. If I've got my Gen AI now assist capability, I can trigger an analysis of that group of alerts. I can see so this is, I can see why they're being correlated together based on those kind of key properties that are getting pulled out of the pulled out of the log payload. We've got kind of a built-in ability, so you don't have to go pivot back to the log viewer. It's got a built-in capability to try and look for any log entries that occurred within the same time frame. Sure why it's not sure why it's not pulling it in. If I go to the log viewer, I can kind of see the raw data.
Hey, well, just want to let you know you have about 9 minutes left.
Thanks, Victoria. Um, So that's that would be how additional data could be kind of surrounding data could be explored, or additional queries, ad hoc queries could be applied as part of the investigation process. And then too many tabs. So the one other piece that I just wanted to showcase was the feedback mechanism. So for any of these alerts that are generated by health log analytics, we give the ability to either raise the threshold by an additional standard deviation, mute the metric entirely, or you can mark it as significant. In other words, emphasize to the system whenever you see this, you should raise it up as an anomaly, or kind of super mute it and say, mute this not just for this particular component, but for all. Okay. Okay, that concludes the live demo, which will take us to wrap up conclusion. So just to recap, we showed you kind of the main components behind HLA. We talked about how it's important because it can find things you don't know you need to look for, and provide the earliest possible problem detection because it's reading right from the logs of your critical applications and infrastructure. Outcomes being reduction in mean time to diagnose, facilitates your progress in your journey towards that predictive IT operations nirvana, and reduce outages. So our last poll question, just to kind of take a temperature and see if we need to reiterate kind of the next steps. If you want to pop that up, Victoria, do you feel like you know ways you could get started with health log analytics, whether that's, we have it and we want to implement it, get it off the ground, or we don't have it and have learned something about it that piques our interest? What do we do next? Okay. Well, it's promising. Nobody's saying just a flat no. There are some folks who indicated they need to learn more. So, um, resources for learning more. You've got, for one thing, you've got this QR code. So with this QR code, that'll take you to a form where you can kind of express your interest and get kind of get a contact from within our team to get you the information, the additional information that you'd like to get, whether that's, a specific demo with your product, with your account team, further kind of insights from a product perspective, etc. So that's one vehicle. The other option you have is just, talk to your account team. Say, I'm interested in these things of AIOps. I'd like to learn more, or HLA. I'd like to learn more, please. And be sure and mention, if, especially if you've already got the product and you're kind of working on your strategy to get value, um, absolutely mention that that ITOM innovation architect team to your account team and say, hey, can we have a conversation with them about maybe getting some ITOM capability launched and kickstarted? They are, anxiously waiting to work with all kinds of customers to get them to value quickly. So some upcoming events. And the link that Victoria had put in chat early on includes these events in the schedule. So that would be the vehicle for signing up for any of those. We've got What's New in ITOM coming up in March, ITOM AIOps office hours in April, which are really useful. Come, bring your tough ITOM questions and get answers from subject matter experts. And upcoming customer AIOps workshops, the community blog will be the source for hearing about those when those get announced.